I was gonna say make some noise, but you beat me to it. Woo! Feeling pumped. Super excited to be here. As you might have guessed from my accent, I am actually half Italian, half English, but by judging by my name, it looks like my dad won the argument about how to name me. I live in the UK. I work at Quantsite Labs on pandas, polars, and other fun dataframe-related things, and I'm here to tell you how you can make a library which is dataframe-agnostic, which can support different libraries without requiring any of them. Super excited to be here. PyCon Italia 2024. Woo! And it's fun to compare perceptions of Italy from outside and from inside. There's one inaccuracy in particular I'd like to address, and that is sign language. Outside of Italy, people seem to think that Italians are just unable to speak without pinching their fingers and rocking their wrist forwards and backwards. No matter what they say, people think that you need to do a bit like this. The story is a lot more complicated, though. It looks more like this. There's a whole variety of gestures that Italians do. This is not a meme, this is all real. All of the Italians in the audience, you all do all of these, I've seen you. But only the top one on the left is the one that people outside of Italy know about. So I thought I'd take the chance to teach you what is the correct way to use it. You only use this one when you're questioning what somebody is saying. So if somebody says something absolutely ridiculous, you should say it back to them, but do like this. I'll give you an example. Luigi. Mario. Luigi, we have 2 gigabytes of data to process. We should use PySpark. Use PySpark. If you want to put this into practice at the conference, people will be very impressed with you using Italian sign language correctly. Anyway, that's enough sign language. Let's talk about data frames. I'm going to start with a trip down memory lane. Why do we have so many data frame libraries? And we're going to have a fun interactive pub quiz. We're going to have a left side of the audience versus right side of the audience. Then I'm going to talk about the solution which is often proposed, which is just convert to pandas, and I'll tell you why I find that terribly unsatisfying. But I'm not just here to complain, I'm also here to propose solutions. So in part 3, I'm going to tell you about how you can do much, much better. And this is going to feature a world premiere. Never to be seen or heard again. I'm going to try to do some completely improvised live coding based on audience suggestions. It's either going to be a train wreck or a car crash, not really sure which. Maybe there's a reason nobody has done it before, but I think if I don't try something crazy in my home country, when am I going to try it? You seem like a friendly audience, so let's do it. Finally, I'd like to end my talk with a message of hope. I'll tell you about what I think should come next. We can then have an engaging Q&A. At some point, it's probably going to fizzle out into an awkward silence, at which point we'll declare the talk to be over and we can go for lunch. Right, ready for a pub quiz? All right, thanks, Luca, for pumping the audience up. So the name of the game is, do they return the same result, yes or no? On the left, we've got some pandas syntax, and on the right, we've got some polars syntax. Like, the syntax is exactly the same, but my question is, do they return the same result? We're just checking whether 3 is in a series with the values 1, 2, 3. So, from this side of the room, do they return the same result, yes or no? Is this... let's try that again. Do they return the same result, yes or no? Okay, I heard quite a few yeses and some no's in the middle. Let's see if we can get a more uniform answer from this side of the room. Do they return the same result? Yes or no? No! Also quite a mixed answer, so we should probably reveal, let's spoil. The answer is no. Pandas checks if 3 is in the index, and polars checks if 3 is in the values. I'm not saying that one is better than the other. They're just different designs. Both of these behaviors are documented. It's just something to be aware of if you're trying to write code that works the same way for both libraries. Let's try another one. This time, the syntax is different. We start with two columns, A and B, with values 2, 1, 4, 5, and we're just going to try to sort the values in column A. And yeah, the syntax is different, but my question is, do they do the same thing? Is df going to look the same at the end of these operations? So from this side of the room, is the df going to look the same in both cases? Yes or no? Yes. I think I heard more yeses than nos. So let's go over to this side of the room. Are they going to return the same result? Yes or no? I think I heard more yeses in the front and more nos in the back. And as it turns out, the answer is no, because pandas aligns on the index. So when you're sorting the values, it also sorts the index, and then it puts things back in the order that they started with. So it's a bit of an expensive no operation, whereas polars inserts things positionally. Right, I do have one more question, but as you can probably guess, the answer is going to be no. Let's go over it anyway. We've got two data frames which have a overlapping column, and we're going to join based on the other columns. And pandas is going to drop the redundant column, whereas polars is going to keep it, but with an underscore right suffix on it. I hope that this has sufficiently motivated you to consider the fact that writing dataframe-agnostic code is hard. Let's take a trip down memory lane. There's a lot of data frames out there. Pandas is currently the most used. Polars is also gaining a lot of traction. It's woo! Got a cheer from the guy wearing the Polars t-shirt. Maybe not too surprising. Dask. I didn't see any Dask t-shirts, so maybe that's why we didn't get a cheer for that one. Anyway, if you do hear your favorite data frame library and it's not one that's already been called out, please feel free to give a cheer. I like a bit of audience interaction. Right, we've also got Modin, cuDF, koalas, Daft, Grizzly, and on my way to the conference on Reddit, I learned that a Japanese group has created fire ducks. If I ever go into a coma, the first question I ask when I wake up is going to be, how many new data frames are there? And please tell me that they don't all copy the pandas API. Because the way that the data science landscape has typically reacted to pandas and all of these other libraries has been by supporting pandas. And nothing else. There's 4 reasons why I think that's an issue. So first of all, if your library only supports pandas, then you're forcing users from other libraries to convert to pandas before they use your library, and then to convert back from pandas after they've used it. This is a bit annoying, not super ergonomic. Second, if data is starting on GPU, you're forcing users to copy that data to CPU. If you do this repeatedly, it can get quite expensive. Third, this is one that I really care about. If your data started lazy, then in order to convert it to pandas, you're going to have to materialize it. So even if the operation you were doing could have stayed lazy, well, too bad. Need to convert to pandas. And finally, pandas isn't exactly a lightweight dependency, and it's likely that it's going to become even less lightweight in the future. So in effect, only supporting pandas forces pandas to be a required dependency everywhere. And there in the top right, you can see an actual, real sign I saw once at a protest. Somebody unhappy that pandas was the only library supported by the DataFrame ecosystem, data science ecosystem. Can we address any of these? Now, there's one solution which people often propose, which is a library, even if it's written in pandas, it can just convert to pandas on the user's behalf. And there's a few ways to do this, like PyArrow, DataFrame Interchange Protocol, searching if the object has a to_pandas attribute, and then just calling it. And in the best case scenario, it would look a bit like this. The user comes in with dataframe X, you do a 0 copy conversion to pandas, and then you just write everything using pandas. Now, the 0 copy conversion is typically not quite accurate, but even in the best case, I think this is terribly unsatisfying. And I'd like to show you why with an example from a library I really like called scikit-lego, which provides some extra building blocks on top of scikit-learn. Let's take their function add lags. Now, they've got a branch in which they've added native polars support. So if we start with a polars data frame and we pass it to this function, then yeah, it takes about 4 milliseconds. But if we do it converting to pandas, passing pandas to the function and then converting back to polars, it takes like 30 to 40 times longer. That's just because polars is really good at doing this kind of operation. So I just wanted to make the point. If a library converts 2 pandas for everybody instead of running things natively, it's kind of unsatisfying. I don't care how cheap the conversion is. There are some things that pandas just isn't that great at doing, but which other libraries do pretty well, so it's kind of unsatisfying. And if anybody ever suggests to you that you can just convert 2 pandas, you now know how to respond. Convert to pandas. In terms of the 4 problems of only supporting pandas, I think converting to pandas on the user's behalf only addresses the first one. It's a bit more user-friendly if users don't always have to write to pandas and from pandas, but it breaks like GPU acceleration, breaks query optimization, and pandas still has to be a required dependency. Can we do better? Woo! I like your optimism, Luca. And I think we can do better, and I'm going to have to introduce this next section of the talk in the most Pythonic way possible. And now for something completely different. And now for something completely the same. Let's talk about Narwhals. Narwhals provides a super lightweight compatibility layer between DataFrame libraries. The idea is that as a library, you can accept any data frame, you can just wrap it in a Narwhals class. Narwhals will then translate whatever syntax you write to the native library's own engine, and then you can give it back to the user in their native class. So like this, as far as the user is concerned, Narwhals is just happening under the hood, but as far as they are concerned, they are just passing their own library and getting their own library back. Let's check out how this actually works in practice. And it's now time to do a bit of live coding. I thought it would be fun to start a Thursday morning talk with a feel-good dataset. So here's a collection of thank you, Luca. My assistant is now going to come on stage. This is a series of passengers from the Titanic. We've got some details about them, and we know for each one whether they survived or not. And my question is, what do we want to know about this dataset? From this side of the room, what's one question you'd like to ask this dataset? Percentile of the age. Which percentile, sorry? 42, wow. Okay, from this side of the audience, what question would you like to ask of this data frame? How many male and female just in total? Okay, cool, yeah. Let's just write these 2 down, and maybe, Luca, do you want to get the audience all fired up? Let's get one more suggestion from them.
Okay, didn't expect this. So, how young was the youngest passenger and how old was the oldest one? There's another one from the audience.
Can you do like average or like survivor, count of survivor pivoted by class and gender?
Wow, okay, that's a really demanding one. So,
By class and gender.
right? Was it this one?
I think we had one more, but I've forgotten it. Do you remember?
The youngest, the youngest guy and the oldest one. Oh, there's one on the bottom.
All right, let's just check how we're doing for time. Whoops, I didn't start my timer. Anyway, looks like we're about 17 minutes into the talk. Maybe let's start with, let's see how far we can get. Right. So I think the survivor count by class and gender is probably the most interesting one to start with. So let's do that one, and then let's see how far we can get time depending. So I'm going to start by just trying to write a function which can accept either pandas or polars, and it should work for both. So pandas and polars. So if is instance, oh dear, is my autocomplete not working? This is going to be painful. I cannot really type, and I can't remember pandas syntax too well, but let's try it. So group by, we are going to group by, so p class and sex, and then we need to find the survivor count. So survived, count. So survived is a binary column containing the values 1 or 0. So to find the count, we're going to sum them. And finally, let's return. Then, if it's polars, if is instance df any pl.dataframe pl.lazyFrame, then we're going to return df any.group by p class sex aggregate pl.call survived.sum. Right, I'm absolutely terrified of running this, especially because without autocomplete, I'm practically certain that I've done something wrong, but I signed up to doing something crazy, so I'm gonna take it until the end. Let's try passing a pandas data frame to this, and let's see what error we get, and then let's see if we can fix it. Okay, let's see what happens. Okay, we got it. Okay. Thank you. Let's try with a polars data frame. And now, okay, looks like this one has worked as well. However, does anyone like this code? Yeah, I don't like it either. So there's a few things I don't really like about it. One is that we've had to duplicate the logic. Like we've got two different syntaxes. We've got group underscore by and group by. We've got this get item. Here we've got ag. And it only works for pandas and polars. We might then have to add like a fire ducks branch as well. The other thing that I don't like is that the output isn't really exactly the same. Like in the polars case, we got a data frame back, whereas in the pandas case, this is a series with a multi-index. And I think we can just fix that with as index is false. Okay, like this, it looks a bit more consistent. But yeah, it's not always easy to remember to do this. As index equals false, it's quite easy to get all of these details wrong. So let's see if we can do better. I'm now going to copy and paste this function. And I'm going to import my super secret tool, which is Narwhals, as NW. Narwhals func. Let's get rid of the pandas part. Then we're going to do step 1, which is df equals narwhals.fromNative df any. Then we can just use a subset of the polars API, which in this case just means replacing PL with NW, and then we can return narwhals.toNative result. And let's get rid of this white space. Does this look like it's going to work? df any from native, group by class, ag survived.sum to native result. Well, let's see. My heart rate has now increased to 300 beats per minute, approximately. Let's see if it now runs for pandas. 1, 2, 3. All right. Thank you, everybody. Let's see, does it work for polars? All right, we've got it. And then finally, what about polars lazy? Okay, and this returns a query graph. So if we want to see the results, we're going to have to do .collect. And we get the same results as before. Okay, we did it. So to summarize, what have we done here? We started with a function with multiple if-then statements. The pandas block and the polars block, somewhat difficult to read, and we had to remember to do this one to get the same class in the output. And we got to a simple function, which is a fairly readable syntax. There's no complications. Narwhals deals with complexities for you. And this will support pandas, polars, Modin, cuDF, and in principle, any other data frame which chooses to be compliant. Luca, let's try one more. Just to demonstrate that this isn't totally planted. Right. I don't know. Let's do male versus female counts. Should be fairly straightforward. But the way that one would work would be like this. One last one, then we'll get back to the slides. Need to say a bit more about narwhals. So for this one, we could just do we could just use value counts, to be honest. That's probably the easiest thing. But value counts is something that you can only run on a series. So the way we do that in Narwhals is to say eager only true, because polars doesn't have a lazy series. And then we could access the sex one and do value counts, and then return that back to the native library. So let's try this now. If we pass a pandas data frame, we get these counts, and if we pass a polars data frame, then we get the same result. I think we're going to run out of time, so I would love to go through all of these and spend the whole talk just taking audience suggestions, but we should probably get back to the slides. Thank you, Luca. Applause for Luca. Right, thanks everybody. Now, I was convinced that my live coding endeavor would end up in flames, so I prepared some backup slides, which we are now going to skip. I told you that Narwhals supports a subset of the polars API, so let's see how far that goes. Does it go far enough to be useful? I've tried running some TPCH benchmark queries using Narwhals. We can do the first 7, probably more, just need to invest a bit more time into it. And these do a variety of group bys, joins, filtering, aggregation, selection, concatenation, and more. So even though Narwhals is initially just limited to fundamental operations, anything that's useful to open source projects can be considered in scope. So please open your feature requests on GitHub. In particular, we love open source, and there are some projects which are now either adding or considering adding Narwhals as a runtime dependency. Got time-based CV, Scikit Playtime, which is a fun experimental project, recommend checking it out, and in progress is Scikit Lego. This is just in a development branch for them, but it looks like they're considering making a release. I'm hoping that they follow through. Would be pretty exciting. And I hope that we can see more libraries join this list. Now, we love open source, but we are not open source absolutists. And we want to give closed source libraries a chance to be compatible as well. So libraries that are closed source, they need to do a bit of extra effort to be compatible with Narwhals. They're going to have to implement the specification themselves, but if this is what they want to do, there is a mechanism for them to become compatible. So what does Narwhals achieve? In terms of the 4 problems which we talked about earlier of just supporting pandas, as far as the user is concerned, they just pass their data frame in and get their data frame out. So as far as the user is concerned, the user friendliness is achieved. Narwhals only translates syntax, so computation that started on GPU can stay on GPU, computation that started lazy can stay lazy. And finally, Narwhals is about as lightweight as it gets. It has 0 required dependencies, and so you can just use whatever the user passes in without mandating any data frame library to be required. We've covered a lot of material today, so in confusion, what have we talked about? First, we saw how there exist a lot of data frame libraries, but unfortunately, typically only pandas has been supported, though things are starting to change. We've talked about how just convert to pandas is a really unsatisfying solution, and that native polar support can often be off orders of magnitude faster. And then I presented Narwhals as a potential solution to this problem, which lets you support multiple data frame libraries with only a lightweight dependency, which respects eager versus lazy execution and CPU versus GPU execution. I would like to end today's talk with a message of hope. What do I hope that we'll see in 2024 and 2025? So first of all, I hope that many more libraries will add support for polars and other dataframe libraries without converting to pandas as an intermediate step. I hope that the future of data science becomes more dataframe agnostic, that data science libraries just define some operations, and then the user can pass in their own dataframe library, and computation will be dealt with by that library. And finally, I'm personally really excited about the Polars project, so I really encourage you to try it out when you're starting new data science projects. You know, for legacy ones, if it's not broken, don't fix it. But for new ones, I'd really like to encourage you all to embrace Polars. In particular, if you complain about the lack of Polars support somewhere, and somebody tells you that you should just convert to pandas, then what do we think? Is that a satisfying solution? No. Right, so if somebody suggests it to you, then we now know how to respond, and we're going to do it in the most Italian way possible. On the count of 3, convert to pandas. Right, thanks everybody. It's been amazing, thank you so much, so kind of you.
Okay, thank you, Mark. It was great. Okay, so we have right now one question on Slido, which is, have you seen the XKCD strip about competing standards? Okay, it's a yes.
Say something about it?
If you want, or if you want to, I don't know.
Oh, yeah. Well, I mean, the XKCD comic about standards, for anyone not familiar with it, they just show somebody saying, this is ridiculous. There's like 12 different APIs. Let's add a new one which is going to solve everybody's problem. And then a few years later, there's now 13 competing standards. And I was well aware of that, which is why I intentionally decided that we need to start with the 2 most popular dataframe libraries, which are pandas and polars. And we need to pick a subset of one of them to try to standardize. I initially tried to make it a subset of the pandas API, but as it turned out, trying to squash polars into a subset of the pandas API is really painful. Like in polars, we've got dataframe, lazy frame, series, expression. Trying to squash all of that together into just dataframe and series, it leads you to some really unintuitive rules and really unergonomic behavior. I then tried the other way around, like just squashing pandas into the polars API, and it just worked wonderfully. So I was like, all right, let's just publish this on GitHub and see what happens. So I'm aware of it, and I would like to think that I'm addressing it by not introducing something new, but just by letting you use what you already know. I can see somebody raising their hand. I think the expectation is to write the question on Slido, but okay. Sure, sounds good.
Okay, there is just one question more. What happens in the backend of Narwhals? Is the data frame left in a waiting state and then acts based on the type of instructions?
All right, so the fundamental thing to understand is that an expression is just a function from a data frame to a series. So if you have something like nw.call_a, then what this means is, given some data frame df, return to me the column a from that data frame. So an expression, it's just a function. Like a function, it doesn't produce a value yet until you give it a data frame. So Narwhals is just recording a graph of these lazy functions, and then once you put these expressions into a data frame context, it just evaluates them, and it just defers to the underlying library for that execution. Right, I think those were all the Slido questions, so let's turn to the audience. All right.
Thank you. I was wondering, why starting a new abstraction layer instead of just adding whatever backends you might want to IBIS, which solves the same 4 problems, and at this point there's more or less 10 different backends already?
All right. I was hoping somebody would ask this question. So what about IBIS? I'd just like to make a very friendly comparison between the projects. I'm a fan of IBIS. I think it's a great tool. I'd just like to talk about why I don't think it solves the problem which I'm trying to solve with Narwhals. So IBIS is aimed at SQL backends, really. So if you're a user, if you're a data scientist, and you need to do some complicated analyses, which you might then want to deploy to a SQL backend, I think IBIS is a great solution. On the other hand, the package size is a bit heavy. It doesn't give you a way to deal with some data frame operations which pandas and polars support. And so if you're not an end user, but you're a if you're a data science library maintainer and you want the lightest possible compatibility layer between data frame libraries, then I think Narwhals is a better solution. Also, I cannot overstate the importance of this. Narwhals has a cute animal pic on the README, and based on this criteria alone, I declare it to be the winner. I think we had a question here in the front as well. Okay.
Okay, so my question is if one of the backends, or if you have not translated the code to your particular backend, do you have some sort of backup as the default as a conversion to polars or something?
That's a great question. So there's no conversion. Narwhals doesn't even import anything. It only looks at things that you've already imported as a user. So the extensibility part should cover that. So if I've not done something within Narwhals, you just need to define some magic methods like __ Narwhals _ dataframe __. Similarly for the lazy frame, for series, for the expression, for the namespace. There's a few magic methods you need to define, but if you define those, then Narwhals knows what to look for, it knows how to glue things together, and then it can defer to your library for the execution itself. In fact, Narwhals itself uses its own extension mechanism under the hood to support pandas. Like if you look at the source code, there's a little _pandas _like folder in there, in which pandas like dataframes use this extensibility mechanism. And yeah, it would be really cool to see other projects jump on board. Do you have a project? I'm so disappointed, but I hope that somebody else does. I would love to see this happen. Got a question here.
Yeah, hi. I would like to know if support for PySpark is on the roadmap or someone is working on it, because it seems like an addition that may make this very, very useful.
Cool, yeah. That would be amazing. So I initially started with pandas and polars because those are the libraries that I work on, and they're the ones that I think I know fairly well. I'm not an expert in PySpark, but if anyone's interested, this is absolutely 110% welcome. Hey.
Quite closer. So as a panda addicted person, I have to ask you a question. How much is covered? In a sense, we saw that there are actually fairly good working for like group buy and aggregation. But what happens if I have a more complex function that is actually using like this crazy like for loops on group by to do like a more, let's say, customized modification of the data set?
Yeah, that's a good question. I think I might have lost the connectivity. I just wanted to show the API, but oh well, we won't do that. So if you look at scikit-lego, they've got one function in which they're iterating over groups and then doing some fairly customized things. So it does support iterating over groups, but only in the eager mode. So when you call nw.fromNative, if you want to do something really customized like this, you're going to have to pass the eager only equals true parameter.
Thank you.
But yeah, fantastic question. Thanks.
Any more questions? I'll look on slide.
Right.
Sure.
Might be time to go and get some lunch.
Yeah, so we're a bit early. We actually have another talk right now.
Okay, yeah, cool, so.
Okay. Thank you. Thank you, everyone.
Thank you, everybody.